All right, so this worksheet is reviewing sections 1 and 2. Remember that we actually started with section 6, and there are some review from that at the end of this packet. So I wanted to review with you these first couple. Numbers 1 through 6 on the packet are reviewing the beginning of section 1. So the characteristics or the key features of a graph. So first and foremost, remember that when they ask for the axis of symmetry is a line. That's what axis means. And so this answer should be the equation of a line. So it's going to start out x equals, and you have to have that x equals. And then the x value that you're going to put that equal to is when you look at your graph, that imaginary line that's going to cut your parabola in half, the x value that it passes through is the x value that you set your x equal to. So x equals -2 for your axis of symmetry. The vertex, remember, is the point that is either the top point or the bottom point of your graph. So this is it right there. And it's an ordered pair, so it's -2, 1. Now, we have a lot of people struggling with whether or not the vertex is a maximum or minimum value. And I'm really struggling with how to get you to understand it. So, I mean, there's a couple of different ways. First of all, if you have a sad parabola, this is a maximum. If you have a happy parabola, this is a minimum. The other way that I can think of to explain it to you is just think about the definition of maximum and minimum in real life. So if I was to make you look for the maximum of this graph, I would be asking you to look for the highest point. But if I was to ask you to look for the minimum of this graph, even though we don't have it on there, it does continue forever and ever and ever down. So if I tried to find a minimum value here, there isn't one because it goes on forever and ever and ever. So looking at this, that would mean that this has a maximum. This vertex is the highest the graph is ever going to go. This vertex is the lowest the graph is ever going to go, so this is a minimum. Okay, so for letter C here on number 1, this would be a max. Next, they're going to ask for the x-intercepts. X-intercepts are also known as the zeros of the function. Remember, we talked about how we can use the word shift or translate, and it means the same thing. That's the idea here. X-intercepts can be called zeros. They can also be called roots. They can also become called solutions, but they're known as either or, x-intercepts or the zeros. And so when I look for the x-intercepts over here, I'm coming over here and I'm looking for the place where they cross over the x-axis or touch the x-axis. So that's here and here. And we're gonna write them as ordered pairs. So the first one is -1, 0. And the second one is -3, 0. So those are our x-intercepts. And then finally for our y-intercept, that's going to be the place that it's crossing over the y-axis. Remember, the word intercept means intersect. So when you're saying the y-intercept, you're saying, where does this intersect the y-axis? So right here, and that ordered pair is 0, -3. Questions on any of that? So this whole front page is set up the same way because I found this worksheet and I liked these 3 problems. But then I found another worksheet and I liked these problems, but I had to change some of the stuff in the table here. So here it's saying, is A positive or negative? So what I'm asking you to do, and you haven't been asked this question before, is I'm asking you to look at this graph. Based on this graph, I can tell by which way the parabola is facing, whether or not it's happy or sad, whether or not A would be a positive or a negative number. Since this is a happy parabola, my A value would be positive. So that's what I'm asking you in the first box of each of these. Is A going to be a positive or negative number if I was looking at the equation? And because this is a happy parabola, or the parabola is opening up, A would be positive there. Now, the number of zeros, I just told you what a zero was on the previous page. A zero is an x-intercept. So when they ask you for the number of zeros, they're asking for how many times you're crossing the x-axis. So when I look here, I'm crossing the x-axis twice. So there's 2 zeros there. They didn't ask me to name them. They just asked for how many. And then next I want you to list the x-intercepts just like we did on the previous page. List the y-intercepts just like we did on the previous page. It's just a different order. Give the axis of symmetry just like we did on the previous page. Tell whether or not we have a max or a min just like we did on the previous page, and give the vertex just like we did on the previous page. So that's that whole page. And then finally, the last page here. The first group here, 7 through 14, is what you just corrected in your assignment, or what you just turned in as your assignment. This is the transformation. So shifts up or down, reflections in the x-axis, and vertical stretches or shrinks. And you're just going to describe those just like you just did in your assignment from yesterday. And then this last little group of problems actually comes from section 8.6. So you might need to go back and look at those notes. But this is determining whether or not an equation is linear, quadratic, or exponential. And I talked to you about how you can tell which is which. I will give you a hint. There's 3 problems. There's 3 different kind of functions. You're going to use each one once. Any questions? All right, go ahead and work on this, and this is due at the end of the hour.